The James Webb Space Telescope was designed to uncover the origins of everything. But instead, it may have pulled back the curtain on a cosmic truth we were never meant to see. Galaxies are defying expectations, light is warping around unseen titans, and now, with the help of Quantum A1, we're detecting hidden patterns in the data that no human eye could ever catch. It began with a strange spin, evolved into a mysterious ring, and somewhere along the way, an unsettling theory took shape. We might not be gazing out into space, but rather, looking out from within something else entirely. At the heart of it all lies a bizarre anomaly, tucked deep in the vast quiet of the cosmos. Galaxies aren't just spinning, they're spinning in ways that are starting to seriously rattle scientists. In a universe that's supposed to be random, chaotic, and impartial, you'd expect galaxies to spin in all directions. But the James Webb Telescope, our most powerful lens on the universe, suggests something is disturbingly off. When the James Webb Space Telescope began its deep extragalactic survey, scientists expected a random mix of galaxy rotations. But what emerged was far from random. Instead of an even 50-50 split, nearly two-thirds of the galaxies were spinning in the same direction, clockwise, while the rest rotated the other way. At first glance, it might seem like a small quirk. But in the world of cosmology, that's like flipping a coin 1,000 times and landing heads almost every time. That kind of imbalance doesn't happen by chance. It suggests something bigger, something powerful, could be influencing the cosmos on a massive scale. The first to raise the alarm was Dr. Leor Shamir, a computer scientist at Kansas State University. Using data from JWST, Shamir trained an AI model to study the shapes and spin directions of galaxies. What the AI found wasn't subtle. Billions of light-years away, the universe revealed a consistent rotational bias. Shamir double-checked the results, then ran them again. The pattern stayed the same. The deeper JWST peered into space, and further back in time, the clearer it became. The universe seems to have a preferred spin direction, at least in the areas we're observing. That's not supposed to happen. This isn't just some odd fluke in space imaging, it directly challenges the cosmological principle, the core assumption that the universe has no favored direction, no center, no privileged spots. If galaxies consistently spin one way more than the other, that principle starts to feel less like a rule and more like wishful thinking. And here's the unsettling twist, this isn't just about broken symmetry, it hints that something at the very beginning of the universe, or even before it, might have nudged everything into a cosmic lean. Some have tried to dismiss it as a product of observational bias, perhaps the telescope's position or the algorithm's interpretation skewed the results. At first, it seemed like some kind of optical illusion, a trick of perspective. But then, other independent datasets began to reveal the same strange pattern. Observations from ground-based telescopes and older missions like the Sloan Digital Sky Survey, all using different tools and vantage points, started to align. The idea of instrument bias began to fall apart under the weight of this growing consistency. This wasn't just a glitch. Now picture this, billions of galaxies scattered across space and time, all subtly echoing the same spin. It raises a chilling possibility, maybe the universe was born with a rotation, or perhaps something colossal, something ancient, set it spinning. And quietly, in the background of scientific discussion, a provocative idea is beginning to stir. What if this rotation is a trace, a fingerprint from beyond our observable universe? Maybe we exist inside a system that was already in motion long before we came into being. What if the Big Bang wasn't a bang at all, but a swirl? A cosmic twist emerging from something deeper, something unknown. That's where things start to get uncomfortable. Because if this swirling pattern is real, not just a glitch or a math error, it suggests the universe has a hidden structure. And structure implies origin. It implies cause. Maybe even intelligence. Now, quantum AI is being brought in to reanalyze this strange galactic spin, not just to verify the anomaly, but to explore how such a directional tilt could have formed. The first AI-generated models aren't just confirming the imbalance, they're struggling to explain it using the laws of physics we know. It's like the universe is dropping clues to a mystery we haven't even learned how to ask about yet. And that's only the beginning. The further the James Webb Space Telescope peers into the void, the more twisted and intricate the spirals become. The galaxies are spinning, yes, but there's something unsettling about it. Because when the universe starts breaking its own rules, it's not just science that gets shaken. It's our entire sense of reality. But the spin mystery is just the beginning. What lies beneath could be even more bizarre, dark matter, or perhaps something even more enigmatic. Imagine this: you've just come to grips with the mind-bending possibility that galaxies across the cosmos might all be rotating in the same direction. Your brain is doing mental gymnastics, trying to process why the universe seems to have a cosmic left and right. But just as you're starting to wrap your head around that, the James Webb Space Telescope throws another cosmic curveball: the puzzling case of JWST. This galaxy happens to sit in the perfect position to bend the light from a much more distant galaxy directly behind it. The result? What physicists call an Einstein ring. It sounds poetic, and it is, but it's also deeply informative. This glowing ring isn't just a beautiful halo in space, it's a powerful scientific tool. It allows astronomers to measure the mass of the galaxy in the foreground based on how much it warps the background light. And that's where things take a wild turn. When scientists did the math, the numbers didn't match their expectations. The galaxy appeared to have far more mass than it should. Right now, as you're listening to this, there could be trillions of other universes expanding inside black holes all across the multiverse, and our own might just be one in an endless series of cosmic matryoshkas, universes within black holes, nested inside even more universes, stretching on forever. Of course, scientists aren't abandoning everything they know just yet. But with new data streaming in from the James Webb Space Telescope and quantum AI sifting through petabytes of cosmic data, this idea is starting to look less like a far-out theory and more like a genuine possibility. And let's be real, if the universe has taught us anything, it's that the truth tends to be far stranger than fiction. Just when the theories seem at their most bizarre, the data always reveals something even more unsettling. Quantum AI isn't finished yet. If the galaxies spinning in one direction served as our initial warning, and the awe-inspiring yet eerie beauty of Einstein rings hinted at an invisible force at play, then the revelation that our universe might be inside a massive black hole was the unexpected twist no one saw coming. But as quantum AI started modeling how a black hole universe could function, something else surfaced: a strange, unsettling anomaly, not visual, but vibrational. Quantum AI wasn't merely analyzing visible images, it was also processing vast datasets of raw signal noise, background fluctuations from the farthest reaches of the JWST's observations. These weren't sound waves, but subtle, low-frequency distortions in spacetime itself. When fed into quantum AI's multi-layered recognition system, distinct patterns began to emerge: rhythms, bursts, and repeating vibrations that appeared across immense distances and in different time frames, yet always aligning. Now, let's keep in mind that if we're inside a spinning black hole, the way spacetime is curved wouldn't only affect the movement of galaxies, it could also create a kind of resonance, similar to the waves that form when you spin a bowl of water. These recurring pulses could be the echoes of the curved structure of our universe, radiating inward or outward based on where the energy is being reflected. In other words, if the universe is a rotating system trapped within a black hole, these vibrations could be the underlying hum of that system, a gravitational rhythm we were never supposed to detect. And this is where things got particularly strange for physicists. Some of these pulses followed patterns that aligned with mathematical sequences, patterns that shouldn't emerge from pure randomness. Prime numbers. Fibonacci sequences. Formulas that suggest there's a design, or at least some kind of intelligence, woven into the very fabric of the system. What quantum AI is detecting doesn't align with any known pulsar, black hole, quasar, or gravitational wave signature. These aren't signs of dying stars or collapsing systems. They're more subtle, and unsettlingly constant. Some theorists are now speculating that these could be the vibrational equivalent of structural stress,